Hello, hello, hello. Hello, hello. Hello, hello, hello. Am I live? I think I'm live. Doing some boring stuff. As always. Oh, let's see. Switch the scene. There we go. It's me. Hello. Let's unmute the thing every once in a while. Oh, there we go. Yeah, that's my voice talking on a 3-second delay, which is really flooding me. No noticeable echo though, even though it is behind the ribbon mic. Every time I pause to say something though, to like consider my next word, and then I actually get a chance to listen to what I was saying in the past 3 seconds, that's what floods me, dude. That's what floods me. That's what floods me. Etc, etc. Anyways, let's get started. Don't worry. I do know that I am still not on the correct OBS scene. Let's change that. No, send it. All right, there we go. Type a message into chat just to get the bot in here. Look, it's the bot. Wow. Lip sync support. All right. Let's do some programming. So, nope, not this one. Not this one. Click on you. Oh, baby. Look how big it is. And then this one, we can just scroll. I think 200 was the optimum amount there. Although 175 is also not too bad, I think. So we don't need any of the editor scripts, probably. I really hope we don't. But what we completed yesterday was the porting of Algorithm RS. How nice. I think this is like a 1-to-1 match to their API. And so of course, like, there are things that could be done better, for sure. For example, a lot of these places where we are, you know, accepting a mutable slice, a mutable reference to a slice of vector, ooh, no, not vector, float 64s. What we could do is just remove this and have it return instead, right? I think a lot of these actually, we can just have it return and it would be so much more, I think it's reasonable, right? Right, they've only done that in Unity because I don't know. I actually don't know why they're doing it. I suppose the Unity burst compiler probably optimizes modification by reference, maybe? I have no idea. Anyways, algorithm, that's in the bag. Actually, probably not. What we should do actually is write some tests for algorithm. So let's just do a very casual Google search for Rust test. How do I write tests again? One of the few things, actually one of the many things that I just don't remember how to do off the top of my head. Actually, doesn't Godot Rust just have tests? I can just look at that, I think. Ooh, how do I search here? When you're this zoomed in, you don't really have. I'm not familiar with the UI. Mobile UI. Why? I don't know. Do you think any of these have tests? Do you think log RSS tests? Probably not. Where do you think the tests would be? Yeah, there's the Godot test, but I probably don't need to use that. Okay. Let's look for things. Let's look for real projects. GD native. What do you use? You think Serde has tests? GD test. GD test. Starting to get kind of warm. Man, today was super cold. Like, not outside, but in my... just in my room. Not my room, my apartment, more or less. I feel like the thermostat, because I have a Nest thermostat, installed it myself, totally didn't break anything, except for the fact that the heating doesn't work. And yeah, I mean, the thermostat said it was 72, but I sleep on like the exact opposite side, like pretty close to the balcony. So it felt more like 60. Oh, just very, very cold. And the fact that I don't really use a normal comforter as well, or a normal bedspread, if you will. Actually, how do you do normal tests and stuff? How do most people do tests? Let's see. Let's look at how N algebra Rust. Don't need to look at the docs RS. Yeah, DimForge, they're pretty good. Let's see. Oh, they just have a separate tests folder. They don't do any of the inline testing like I guess other people do. Okay, well, look at an algebras because they do some fancy stuff here. Okay. Also using some macros. I don't know, that's fine. Then would I want to use mod test? Configuration tests. Okay, well, let's just do it how the book says to do it. I've read this before, but it never clicked with me until Because I still have not gotten around to writing tests at my job, either. In Rust, at the very least. Yeah, so let's just copy whatever they're doing. We'll need tests here. I'm assuming that they put it inside its own module to namespace it. That makes sense to me. How does NAlgebra name their tests? Prop test. I guess they just call it exactly what it's testing. Yeah. That would make sense to me. Unused import. Mel to Hertz. Right. Mel to Hertz. And then we'll need to do like an assert equals at some point. Well, mel to Hertz to mel, right? Well, mel Hertz conversion, I suppose. Hertz mel, mel Hertz. Mel Hertz flows off the tongue a lot easier than Hertz to mel. Hertz mel. Mel or Hertz. Yeah, it's because the Hertz has a hard stop, whereas mel is kind of like mel, mlim. So mel, Hertz, conversion. So we'll just go like roundhouse, I suppose. So what's like a normal, what's a normal conversion number? I don't know. What's a normal Hertz? What Hertz do humans hear? Human Hertz. Hearing range. Yeah, right, hearing range. 20,000 to 20. I don't know. What is speaking voice? What Hertz do I talk at? Speaking Hertz. Oh, sure. It's about 100 to 120 for men. I don't know, I'm just looking on Wikipedia. Narrow, ooh, still don't know. Voice frequency doesn't really help me. Telephony, 300 to, what? I don't know, man. Just give me the Hertz. Average fundamental frequency for a male voice is 125. For a female, it's 200. I don't know, let's split the difference and call it 150, so we'll just hit it with a 150. That's always good. So they're using assert equals. Do these relative equality, assert equals. Yeah, we'll just use assert equals. That's easy. That's easy. So let's look at what Godot Rust was doing. Godot Rust. Also, don't want to deviate too far from wherever they're doing. What are they doing? What? Test? Public extern. What? Oh, they're testing like various. Oh, interesting. So they're testing like the C API as well. That's pretty neat. Alright, but are you telling me they don't have any tests for these? I suppose it would be in mod RS if anything. At the very bottom. Maybe not. Wasn't I just in core? That's alright. So I don't really know what these functions are supposed to do, but we'll probably just hit it with one of these. Something similar to this at the very least. So this will be test, some sort of test macro. And then we'll just go from mel to Hertz back to mel. So mel to Hertz, wait. Yeah. Wait, no, to mel and then back to Hertz. So we'll do 150. So this is like assert equals... I guess like let base hertz equal... So this needs to be an F64. We'll call it 150, right? Assert equal... So it would be 2 mel. Wait. And then back to hertz, right? So it'll be 150, or base hertz, right? And then this one needs to be 2 hertz. So this is basically useless, but there we go. Should be all right. Give that a save. We can run the test as well. Look at that. We're compiling. We'll take a little bit. Everyone loves a good compile. Luckily, this computer is pretty beefy. And by pretty beefy, I mean like extraordinarily beefy. It has the beef to not make this like a huge pain. And also the project is very small, right? Like even like, I think my work computer has a stronger CPU than this one. Okay, that's good. So we panicked. Oh my God. It's close. Floating point error. Nice. Okay. Okay. I guess we can round. We can round. But we will start to stack up floating point errors. How do I get like a relative equality? I can see here that N algebra uses a relative equality, but I'm not sure if that's... Yeah, I don't think that's like a thing that I have access to. That might be one of their own macros that they've defined. So we can just round instead. Everyone loves a little bit of rounding. Nope. What was the thing? Why did we panic? We panicked because... Wait a minute. That doesn't make sense. Run the test again. Run me again. That's good. Oh, it's because I should have rounded this one, right? I rounded the incorrect paren. Yeah, okay. Cool. All right, there's the mel to hertz conversion, and then we can go, mel. We can go in the opposite direction. What is mel in terms of audio? Mel audio. What is a mel? Mel frequency seption. Okay, sure. Mel scale is a perceptual scale of pitches judged by listeners to be equal in distance from one another. Is that what I want? How about Mel frequency sepstrum? Sound processing. The Mel frequency sepstrum, MFC, is a representation of the short-term power spectrum of a sound based on the linear cosine transform of a log power spectrum on a nonlinear Mel scale of frequency. Mel frequency sepstrum coefficients. Oh, yeah, MFCC are coefficients that collectively make up an MFC. They are derived from a type of sepstral representation of the audio clip, a nonlinear spectrum of a spectrum. The difference between the sepstrum and the Mel frequency sepstrum is that in the MFC, the frequency bands are equally spaced on the Mel scale, which approximates the human auditory system's response more closely than the linear space frequency bands used in the normal spectrum. This frequency warping can allow for better representation of sound, for example, in audio compression. Sure. What's a normal Mel? Just give me the normal Mel. 400 hertz is roughly... yeah, that's okay. Yeah, give me 257. Sure. Let base Mel also an F64, equal this number here. And then we'll just assert equals. So we'll go in the opposite direction, right? Or actually, can't I just use... I don't need to go like all the way around, right? Like I could go all the way around, but I don't need to. Right? So as long as I go from one to another, it's fine. So this is like, that's a round trip, I suppose. So this is the, you know, round trip. Which might be the most obvious one, but then I think we would just want to convert flat numbers. That should also be pretty easy. So let base mel equal, ooh, no. So this one will be hertz to mel. So what we want to do is to mel, hertz to mel, so base hertz is equal to alright, let's not use 150, let's use 161, because that's what they're giving me. I wonder if these are rounded or not. They might be rounded now that I'm thinking about it. Right, this will be mel to hertz. We're learning. So this is 2 hertz. We want the 2 hertz, the mel. So this will be base mel. Ooh, should give us base hertz. So run the test. Give that a try. How many things failed? We got a few panics. 1 failed. That's good. Okay. Okay. Call once, sure. We panicked, yeah. Ooh. Okay, so we can just do this, right? So like const. We can just set these as constants, I suppose. So this will be base hertz, right? Const base mel. Don't use these anymore, so then I'll just split these up. So func hertz to mel conversion. This one should be function mel hertz mel, or mel hertz round trip. Split it up just so it makes more sense. So this is mel to hertz. This one is, okay, grab this, base mel. This is base hertz. Grab this, round trip. Doesn't really matter the direction, I suppose, or which one we do first, because they need to go through both functions. So I'll just use hertz, base hertz, and then there's the mel. I guess mel actually just stands for melody, huh? That's crazy. There's text. Hit that with the test. Hooray for tests. Can I not just run all the tests? Or did I structure it wrong? In this case, it's not my fault, because this is how the book tells me to do it. Checking for panics with should panic. Neat. Yeah, okay. This looks about what I remember. Cool. So just run this. We might need to, oh, you know what? We do need to round, I suppose. Oh, actually, no. Mel 2 hertz. Wait a minute. Wait a minute. Is this wrong? Other functional forms for the Mel scale. Point out. Oh no, these use a different formula than I'm using. Oh, so what am I doing? What am I doing? I'm using a different formula, that's why. They're using, or what am I using? So the Mel is equal to the natural, oh, they're using base 10 log, right? I'm using the natural log. A popular formula to convert hertz, a popular formula to convert some F hertz into mLs is 2595 log 10 of 1 plus hertz over 700. So I am using hertz over 700 plus 1, yeah. But I'm taking the natural log and then multiplying by 1127. So I'm wondering, why did they deviate? That's a bit tough. Okay, so I can't just look for specific numbers, but at the very least I can tag these specific ones. Right, so this one should be fine. That's all right. I suppose everything does need to be rounded since we are 100% going to run into floating point errors. But that's only relevant in the tests. So during actual usage, it shouldn't matter since we are looking at like very small slices of the data at any point in time anyways. And we only reuse them for a little bit. So the floating point errors should not add up in theory. Maybe, I have no idea. But I don't think that these convert well, probably. So let's just find out what these should be, and then we'll do a thing. So left is 179. Right is 169. Nice. Wait. Ooh. Well, let's tag the hertz. So hertz is what we want first. So let's find out what the incorrect mel is, and then we'll just tag it there. So should have gotten 233 with our calculation. I wonder if their calculation is just a bit off. So let's add it to do. To do this calculation. Calculation seems a bit off from the Wikipedia formula. But it's the one that they're using, so what can you do, right? So that's okay. That's okay. Neat. Okay. We have tests. Hooray! Test coverage. DCT. I don't know. I don't know. Mel filter bank. Also don't know. Is there another easy one that we can use? Like get max value seems pretty easy to write a test for. So opening up algorithm RS. I guess we also don't need this because that's like a stream. Don't need to use a stream. What is this? Get RMS volume. That's okay. So in the tests, let me see. So this should be get max value test. Of course, it's going to be a test. Now, What are we going to put in as the value? I mean, this one's pretty easy, for sure. I just wish the reference thing that I was looking at had an actual test suite attached to it. It's very sad. Very sad. So just assert equals get max value of some sort of array of F64s. So get max value of, I don't know, we can just pass in like a vec of, I don't know, 1, 2 should be equal to 2, I suppose. I mean, that's easy, right? If that is what it's supposed to do. Look at that. Oh my god. Expected a, okay, as slice. Sorry. As slice. What's your problem? Mismatched types. Try that again. Okay, cool. Well, let's do some other really easy tests as well. So given that, then it should give me this. So I wonder, is this wrong, by the way? Now I'm taking another look at it. The fresh eye. I don't need to look at any of the editor stuff, but the runtime core algorithm. So get max value. What this does is math absolute. So it gets the absolute value. I guess it's still 2? Is that correct? Is that what this function is doing here? It seems a bit suspect. So for I in array, because this is one of the few parts where I just use for I, or a for each, whatever, instead of the more traditional, you know, for integer I is equal to 0 kind of thing that I've been doing. If I so it takes the max of those two values. And that takes the absolute value of whatever was passed in. I suppose that makes sense. Yeah. That's covered. So that's get max value basic. This one should just be like get max value. Get max value with negative. Just run that by itself just to make sure. Okay. Is there another easy one that I can test? Copy ring buffer. I don't know what I want. Yeah, like that's crazy. I actually don't know what I want here. Yeah. In theory, these should work. We can just test them to make sure that they run at the very least. So what I can do is like write failing tests, see what the output is, and then just, you know, assume that it's giving me values that are valid. But at least we know that the function is able to complete without, like, seg faulting or whatever. I think it's very unlikely that we'll actually seg fault, but you never know. So this needs to be some sort of assert equals. So we'll just do it with 2 values. And let's just see if we can find out what it's supposed to be. So this is an excited vector of 1, 2 as slice. Pass that in. I don't know. I have no idea what this is supposed to be, so let's just give it a run. Run the test. Fail. Panic. Nice. So what were you expecting? Okay, how do I round this some value? So Rust F64. So what do you got? What do you got? Rounding. I suppose sig num is probably what we want. No. That's a sign of the number. How do I round to a... Or how do I get... Significant figures. That would be sick. Rust. Sig figs. It's not clamp. I know that. Total compare? Probably not. Big endian, little endian, no. Native endian? No. From bits? Probably not. What would I want here? Not seeing anything that would be super useful for me. Fraction, probably not either. Subnormal? What is subnormal? Returns true if a number is subnormal. Ooh. Subnormal numbers are the subset of denormalized numbers, sometimes called denormals, that fill the underflow gap around 0 in floating point arithmetic. Interesting. The more you know. I'll completely forget it, but at least I'll have a, subnormal, floating point arithmetic. They're related. Anyways, I'm pretty sure we don't want to round. RMS volume. I wonder, is there a way for me to calculate that? RMS volume. Sure. RMS stands for root mean square, a metering tool that measures the... Root mean square, a metering tool that measures the average loudness of an audio track within a window of roughly 300 milliseconds. The value is displayed as an average of the audio signal. Root mean signature value will give you a more accurate look at the perceived loudness of the music track for the average listener. Okay. Is that what this is doing? Yeah, you know what? This is just giving me the root mean signature. Yeah, you know what? That's fair. That is what it's doing. That is what it's doing. So let's figure out this part. Don't need the mel stuff anymore. Lip sync stuff, also don't really need that. I don't need that one open. I need this one open, which is the lip sync job, which is going to be the tough parts, right? Rust. Let's see. Decimal precision. Please. Floating points cheat sheet for Rust. Decimal types. Does not have a built-in decimal type, but there are crates that do it. Rust decimal. I don't want to pull in a crate just for testing. I don't know. I suppose we can just round. That's fine. It's good enough. So you're looking for 2. Actually, isn't that just 2? Isn't this is roughly just 2 if I do from 1, 2, 3? Yeah, that's roughly just 2. It's a bit more than 2, but since we're rounding it. So if we do 1, 2, 3, 4, 5, it should give us roughly 3. And then what exactly it gives us afterwards, it's not like, that's more of an implementation detail, isn't it? Don't do it. Okay. Run the test. So it should be roughly 3. Nice. Sick. What else? What else? So this is covered. Is there a way to calculate test coverage in Rust? Probably is. Copy ring buffer. Start source index. Yeah, we can do a copy ring buffer test, right? So this is copy ring buffer test, or test copy ring buffer. Let's invert it, I suppose. So we don't accidentally get code completion for that. All right, so test. What are we trying to do? So copy ring buffer. I know roughly what a ring buffer is. I guess Rust doesn't come with a ring buffer, but it might. Rust ring buffer. Yeah, there we go. Google's listening to me. Ring buff is a vec-deque is technically a ring buffer, I suppose. A vec-deque, a double-ended queue implemented with a growable ring buffer. Yeah, so I think like a good thing to do here, I guess once I have the basic implementation down, is I can start ripping out some of these algorithm stuffs and replace them with Rust native like data structures as opposed to just using vectors for everything. That would be ideal, for sure. So it looks like a vec-deque would be exactly what I want here. And then I suppose it, you know, already implements copy. No, it implements clone, which is good enough. Good enough, but that's not what we want. Here we're testing this. So let's input equal vec 1.0, 2.0, just easy. Does Rust know what it is? Oh, I like how it's just assumed it's an F64. I suppose that's okay. Assert equals. So this should be copy ring buffer. Oh, and then here's our input, which needs to be a as slice. Let mutable output equal just a vec with capacity. Yeah, with capacity input.len. And then this needs to be a mutable slice, as a mutable slice. So output as mute slice. Sure. And then starting index. I don't know, just hit it with a 2, I suppose. I suppose expected output. What if I do this? If we start at 2, then we were expecting 3, 1, 2, maybe? I don't know. Let's send it. Hopefully it works. Ah! So mismatched types. Expected. Oh, right. This part. We need to copy it here, and then this needs to be output. So what's your problem? Mismatched types. Which type? Which type? So this needs to be a mutable. I suppose it needs to be a mutable slice, not a mutable reference to a slice. Or one of these. No, that's fine, right? Expected mutable reference, found reference, mute. What's your problem? Ooh. So as mutable slice gives you a mutable reference to a slice. Which type is mismatched? So this is a slice. This gives you a reference to a slice. Yeah. Yeah, and then this is an F64. This is an F64. Probably. I guess we can be specific. So this is a vec of F64s. And then similarly, this is also a vec of F64. Right? Is it this one? As U size? What's your problem? I don't know. What happened? Length is 0, but the index is... Oh, it just didn't update. That's cool. Or is it because, like, the Rust just wasn't able to figure out what these are supposed to be? Or is it because it thought I was passing in an integer instead of a U size? So I need to explicitly put as U size there. That could be it. That could be it. So panicked at index out of bounds. Length is 0, but the index is 0. So at algorithm 27, so length is input.length. Okay, so it's good that we're catching this now. But the index is 0. Length is 0, but the... What does that mean? The length is 0, but the index is 0. Copy ring buffer 27. Yep. Length is 0, but the index is 0? Do you think it's gonna let me put a breakpoint here? Kinda doubt it. Yeah, I don't see a breakpoint. Don't see the breakpoint thing popping up either. I wonder. So it is at 27. Length should not be 0. I don't know. Just want to do a print line and see what happens. Must be a string literal, so we can do one of these. And then I should just place it in there. Hooray. So, copy ring buffer. What's the problem? What do you got? Do you think it printed? My favorite type of printing. Alright, so see, yeah. That's correct. index out of bounds. Does output not have the appropriate length? Is that it? Is that output is just not big enough? Output dot capacity. Wait a minute. How to get capacity of a... Oh, I think I see. I think I see is because the length of the slice that was passed in is nothing, right? Because it's an empty slice. Where it's an empty vector and I got it as a mutable slice, right? So it would be like, of course the length is going to be 0, but it also looks like I'm not able to look at the capacity either. Yeah. So the length is 0, but the index is 0. So the index is of course out of bounds at input I equals whatever, right? So even if I do, yeah, because I'm using direct array access or index access. So if I were to do like output, like, because I think I've guaranteed that it's at least 3, right? So if we do like that's technically valid, right? But then if we test that, I will get an error at line 26, right? I think. No. No, yeah. Length is 0, but the index is 1. Yeah, okay. So this needs to be changed to a mutable vec. I think pretty much all these output things need to be changed to mutable vectors. And then I just pass this in as a mutable reference. Right, and that should be okay. Hopefully. Ah! What's your problem? Is it not a vector with capacity? So what does vector with capacity do? Does that not work how I think it works? Rust vec with capacity. With capacity. With capacity. Let's allows to access values by index. You'll panic if it's not in there. Sure. Capacity and reallocation. So the capacity of a vector is the amount of space allocated for any future elements that will be added onto the vector. This is not to be confused with the length of a vector, which specifies the number of actual elements within the vector. When it exceeds its capacity will automatically be increased, but its elements will have to be reallocated. It is recommended to use vec with capacity whenever possible to specify how big the vector is expected to get. Okay. I guess we can just zero it out, right? So I can create a vector. Yeah, isn't it? You can create a vector by doing with a given value. I guess we can just zero this out, and then we'll just have to remember that like that's kind of an implementation detail, I guess. So undo. Mutable slice. And then this one will be, isn't it like vec 0, and then it'll be input len. What's your problem? Found use size. Please. Oh, is this the wrong notation? Found use size. Hey. I think this might be the wrong notation. So that's an empty vector. How do you create an empty vector with things? So Rust creates vector with or fill empty vector. Creates vector with values. Vector of zeros, sure. So that is, yeah. So if we just do this. And that'll be input len. What's your problem? Just to be specific, and then, yeah. Oh, did I put like a comma beforehand? I didn't put a comma, I put a paren. But okay. I mean, that seems to have worked, right? Output clear. Then we can copy a ring buffer again. And then just try it out with something different. Right? So if we start at 1, it should be 2.0, 3.0, 1.0. Right? So this kind of changes. Okay, well, good to know. Good to know. Okay. So we can just reassign the output, I suppose. That's fine. Because it does need to be initialized with something inside of it. Because we are accessing by index. You know what? I suppose it would be easier if we... So this doesn't need to be like the well, it's because it's 0 to length. Okay, so now I'm starting to see the shortcomings in my implementation. Okay, so we can do this instead. So what was it called? It was called pop push. 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 Yeah, push. So you just push it to the top of the stack. So if we just do, oh geez, what am I doing? I don't know how to type. Push. Push. Just push this onto it, right? No method named push for mutable reference. Can you not push onto a slice? You might not be able to. So Rust push or slice push. Can you push? Standard slice. Is there a way? Append a slice to a vector. Creating a slice and appending to it. Rust is a slice is a view into another container, which only allows for observing the container, although it may allow for mutating the individual elements. All right, so that's cool. That makes a lot of sense. Yeah. But now we'll change this to a vector. This changes. And then this also changes. Because I think we would just want to pass a mutable one of these into it, not the slice. I think this makes more sense. Yeah. And then we'll just create like a vec with capacity. So it have an initial capacity, but it won't have any like values in it by default. Yeah, that makes more sense. Yeah, okay. So this it's just easier for me to parse in my head as opposed to having to create something with actual values. Cool. We're doing it. So this is test normalize. So we'll do the normal, or the thing I've usually been doing, because I don't actually know what values I'm looking for. It's a good learning experience in any case. Makes you feel very kind of claustrophobic when I don't have as much space as I'm used to having. So test normalize. So we have an array of a mutable reference to a vector, sure. So we'll get the max value. Test normalize. If max is less than epsilon, what is epsilon? Machine epsilon. This is the difference between 1.0 and the next larger representable number. Excuse me? What? Huh? So that's... What is epsilon? What the heck? Rust F64. What is epsilon? What is epsilon? Yeah? Machine epsilon value, sure. Approximation, an upper bound on the relative approximation error due to rounding and floating points arithmetic. Interesting. Okay. What do you got for source? All right. I'm assuming that this is like a scientific notation. Or no, that's just e to the power of -16, isn't it? Yeah, okay. Well, I don't really know what that. I don't really know what to do in this circumstance. But that's cool, I guess. So if max is less than F64 epsilon, I don't know. Let's check for a little less than F64 epsilon. And then we can send that in as our max. And then we should test normalize less than epsilon. Let less than epsilon. Who wrote this? This will be equal to F64 epsilon divided by... Yeah, that feels good. It'll be rough. It'll be rough. But that's okay. Then we can do, this is our input, so let's input equal, oh no, this is just our vector, right? So this should be a constant, shouldn't it? Yeah, I feel like that should be a constant. Can you do constants like this? Like a constant thing that's evaluated, or no? Missing type. Provide a type for the constant. F64. So it's just pre-calculated, so less than epsilon. It's just a little less though. Okay. Beautiful. Fantastic naming scheme. And then less than epsilon divided by 0.9. Or no. This should be times 0.9, not divided by. Right, and then we want to run input. So this needs to be a mutable input. So we'll hit it with a normalize. A mutable reference to input. Then we just assert equals input is equal to whatever the heck this was. This is like less than epsilon and then even less than epsilon. Sure, let even less equal that. Is beautiful. How does he come up with these? Nobody knows. So that should be fine, right? Because here it looks like nothing should happen. Yeah, beautiful. Oh, hello. Hello, Knock. Congratulations! You have successfully rolled some sort of duck. Some sort of avian, if you will. How are you doing today? Acceptable. That's fair. It's hard to beat the kind of jank rubber duck that I drew. Just freehanding it. I'm writing tests. Are you proud of me, Father? I think the hard part about writing these tests, though, is that the original library doesn't have tests. So I have close to no idea what I'm supposed to be looking for. So what I'm doing is just kind of tagging things. So like copy ring buffer, I think it's also pretty helpful because it's allowing me to see which things I could potentially rip out. So, oh, hold on, get out of here. Forgot to write a comment for this one. So like to do, this could be like a vec, or like a vec de. Since I think this is essentially just a ring buffer in Rust, RMS value, I've totally forgotten what this stands for. Well, there's a few things like copy ring buffer. This should use this thing, but even better, it could be a whatever this data structure is, a vec de. Normalize. I don't know. I don't know what it's looking for. Like I understand the algorithm, but it's a little scary. I did learn what epsilon means though, which is I guess the floating point error. But I'm just kind of assuming what I need to use. So like, this is pretty good. We won't use any of the less than epsilon stuff here. Oh, and this only needs to be used in this one function because if our max value is, well, test normalized success, and then I guess we want to use epsilon in one of them as well, because it's only checking for the max value. If your max value is less than the floating point error, then we should just immediately return. Yeah, that makes sense. That makes sense. Here we don't want to use less than epsilon though. We just want to pass in probably just like normal values. And let's see, what are we looking for here? So we'll normalize it, a mutable reference to this vector, and then what are we asserting equality to? Our input should be equal to, it's divided by max. So that's roughly, oh no, we're gonna hit floating point errors, aren't we? Yeah, we are, yeah. Because it'll be roughly half. And then this should be roughly 1.0, but because of floating point error, that won't be true. So this will fail. Yeah. Or no, did it work? Oh, well, there we go. That doesn't seem like it should have worked. Hold on. Who needs a debugger when you just have print lines? Oh, that's good. Doesn't implement display. All right, fantastic. Just give me the first element on you then. Ooh. Yeah, okay, cool. No floating point error, but that still seems wrong. Of course, this is going to hit a floating point error, though, once I test, like, normalize with epsilon inside of it. But that's probably good enough. At least you seem to have made significant progress. I have. I have ported over the entire algorithm file from C#. Been trying to get sound working. Nice. Does MacroQuad has sound support, right? Death Pop Sounds music isn't the best. Yeah. The way I implemented it was kind of weird. That's why it's actually kind of broken as well. Very rudimentary. Yeah. It's not great. It was the last thing I did, so I started running out of time. MacroQuad support, I mean. Yeah. Like, I think the idea is okay for what I did with Deathball's stuff. What I don't remember how I did Deathball's sound. Did I do everything in like as like a global sound handler or no? Do you want to remaster the sounds? Oh, absolutely not. I'm not going back to that. Add normalize test with a low epsilon plus 1.0, and it's not the sound code that's bad, it's the sounds itself. Really? Are the sounds actually bad? Like the sounds are made in RFX gen, so like they're meant to sound kind of low quality. So yeah, RFX gen, there we go. So I mean, this is what they sound like. I get what you're going for, or is it like the music is bad? Because the music is kind of poorly mixed. If that's what you're trying to say. The mixing is pretty bad. Low pass filter. Oh, geez. Okay. I don't know what I would be looking for here. Low pass filter. Low pass filter. So how does this use it? So there is low pass filter. So we have some sort of buffer that is copied from a ring buffer. Input get what? What? All right, where does input come from? Ooh. Get vowel, no. Hit. Ooh. Did you actually implement a ring buffer? I did actually implement a ring buffer. Well, no, I didn't actually implement a ring buffer. I'm just using an array. But I did leave a note saying that this should be replaced with just a vecdq. However you pronounce that. I know that that can be used as a ring buffer, right? But I'm just copying their API pretty much line by line. That's why it's kind of, it's nice, you know? Writing tests, I'm looking at things that could be made better, adding notes to things, etc. How does this ever get set, by the way? If this doesn't have... Ooh? That's a bit confusing. So, lip sync job. Lip sync job. Where's the job? Job handle. Probably this. Job handle is not completed. Job handle completes. Where do you lip sync job? Okay. Oh, that's interesting. Is lip sync job a struct? Oh, it is a struct. Oh. Okay, cool. Input data. Okay, that makes sense then. I was looking for a constructor. I was looking around. I was like, oh, how does this work? if these values aren't set, then how do they ever get set? Because there's no parameters. But okay, it's a struct. Interesting. So then your volume, your ring buffer is just your input. So I guess your input is always just gonna be a. What is input data? Is input data a native array? Probably is. Yeah, just a native array. Presumably it comes from the audio data, and I guess that's just your ring buffer. Cool. So low pass filter. How this is used is it takes a ring buffer, I think. Yeah. Low pass filter takes the ring buffer, and then what is your output sample rate? Output sample rates. That's one of your struct items. Cutoff is your target sample rate divided by 2. Range is your target. What? Divided by 4? Okay. Okay, sure. That makes sense. Definitely. New lip sync job. So there's an output sample rate, target sample rate. Okay. Okay, cool. Sample rate. Wait a minute. Wait a minute. Oh, okay, these are different ones. Okay. All right, I was looking at this. I was like, wait a minute. Doesn't this mean that they're actually doubling up on their code? But no, this is their output sample rate. This is their target sample rate, which are not necessarily the same thing. Okay. Okay. So let's create a buffer, and then we will, I guess we don't need to copy the ring buffer. We can just create a new vector of some garbage values. It doesn't really matter. Probably. What is n? Where does n is the range? Wait. Wait a minute. Now I'm going back and looking at the code again. Is range not going to be a big value? With capacity, like this is an F64. Who? So it's at least 1. No. Yes. No? Alright, I'm very confused. There's your range. Your range is your target sample. Okay, so your range will be pretty high. Okay, wait. So 3.1 divided by your range. Your range is going to be pretty high, which means that this doesn't make sense. Is there a flaw in my implementation, or am I just understanding this incorrectly? Yeah, I was actually looking yesterday for just other people's implementations of all of these. So there are implementations of some of these. So for the FFT, a fast Fourier transform, there is an up-to-date Rust implementation of that. But for things like MFCC, which I think is implemented somewhere, at least I thought I implemented it, but a lot of these aren't really implemented in Rust code. And there is no real-time lip syncing stuff for Rust. And so like even the thing that implements, even the Rust crate for fast Fourier transforms doesn't have like downsampling or pre-emphasis or whatever. So I think it's better just to keep everything in Rust. So at least I can poke at things more directly. Low pass filter. Low pass filter. Is this correct? I guess it is being rounded to at least 1. Might be 0. Oh, yeah. Wait, no. Wait, yes. Wait. If this is closer to 0, then we make it at least 1. Then we make it 1. Okay. So we'll never have a vector with no capacity. Okay. I think also this needs to be changed to... I think this is something that I also caught with my tests as well, is that this needs to be push. So for pretty much everything, we need to push things onto it. Is this not push? Oh, right. Right, because we're always going for I to whatever this is, right? And then, because this is one of the intermediate things. And then data, this is a slice, but it's a mutable slice. Yeah, I think that's something else I've started to realize, is that a lot of these actually don't, if I'm mutating the data, I want these to be vectors. I don't want them to be slices, because if I pass in a slice, then I need to pre-initialize every single indice as well to 0. Whereas if I just do this, right? Or yeah, data length, if I don't pre-initialize it, then length will be 0, etc. TMP will be wrong. So should actually be doing... That's actually a little tough now that I'm thinking about it. Maybe... No? You know what? No, this actually needs to be a slice, because I think data will always be pre-populated. Because looking at... Oh, geez, I need to write this down. Okay. Data will always be pre-populated because this value is copied because this is copied from a ring buffer. Ring buffer. Which means it's okay to pass in a slice. However, with normalize, actually normalize, I think we can also count on this being pre-populated, yeah. Or copy ring buffer. Copy ring buffer, for now, we need to actually pass in a real vector, because otherwise this will not work, right? Because we need to, the original implementation does index accessing. But I don't think it makes sense to, you know, pre-initialize a vector with just all zeros inside of it. Oh, maybe it might. Maybe it might. I don't know. There's the copy ring buffer test though. Low pass filter. I'm a little nervous about this one. So low pass filter. This one then creates a data thing. So this is pretty much the end of the line for that. More or less. Well, no, that's not true. Buffer goes in, output sample rates. What's like a normal sample rate? Normal sample rate. Sure. 44.1 kilohertz. Sure. I guess prepare yourself. So this needs to be a let's inputs equal, I don't know, dude, just a vec of 1, 2, 3. It's beautiful. Should probably specify that this needs to be F64s, but it looks like Rust has just figured that out for me. We can then low pass filter, on a mutable slice. So input as mutable slice. Sample rates we'll do 44100. .o. Cut off. Cut off is your target sample rates. What are the other sample rates? What other sample rates? Wikipedia, share with me your knowledge. God, I hate numbers. Since this is low pass filtering, wouldn't you want? If I'm hitting this with a low pass filter, would I want to go up or down? I don't know. Audio CD. Sure. Let's hit it with the target sample rate. Let target sample rate, some sort of F64, 48,000. Beautiful. And then our cutoff will be half of that. So let target cutoff equal target sample rate divided by 2. Let target range equal target sample rate divided by 4. Right, so then this will be our cutoff. Target cutoff. Target range. I'm gonna be honest, I still don't really understand what it's doing. So low pass filter, it does some magic, and then it gives me back some data. I don't know. Let's just hit it with an assert equals. Accept that we're going to be wrong really quickly, and then just compare it against an empty vector and see what happens. And like, these are kind of bad tests for sure, but that's because I don't know what I'm looking for. So what do you got? Okay, so that didn't even do anything. Should this target sample rate, should this have been lower? Should this have been lower? Or no, should this have been higher, actually? So this should have been 4,800, and then this should have been like that. So we flip these. Nope. No, they're the same. What? Do these need to be higher values for anything to actually happen? I don't know. I don't know. Let's make this, I don't know, it's just basically someone making very robotic square noises into the the mic. The robot uprising is real. Nope, that's the same thing. Okay. So it does not appear to be doing anything. But we should be modifying the slice, but the like that's not correct. Right? Okay, so for I in 0 to data.length, so the data.length is just the mutable slice, right? And then B length is just B. B is N. Wait. Wait. Wait a minute. What is this? What is this? What is B.length? I'm a little suspicious now. There should be at least one, right? Or did it not even run? Is that the joke? Yeah, okay. So the joke is that it didn't even run. Let's see. Or no, that's the capacity. Oh. So yeah, okay, so nothing ran because it needs to be... Hold on. This should just be n as u size. Right, because we're taking the b, the length of b, which is just the same as n. And then this is also n. What's your problem? Ooh. As u size. So anywhere that I see b length, that should just be as u size. Then this is... I suppose this can be a u size as well. What is I? What's your problem? Cannot subtract integer from F64. Ooh? Ooh? Cannot subtract x, so u size minus F64 as u size, sure. So then this should actually run now because we're no longer getting the length of an FD vector. Okay, that's good. That would have been very confusing for sure. So what do you got? We panicked. Okay, okay. Panicked at attempt to subtract with overflow, 57. So these are u sizes. Because it's a u size. Okay, so this is okay. I needs to be as I64. What is your problem? F64. Ooh. I64, sure. Yeah, that should be okay, probably. I don't know. We're just trying things out. Test failed, that's good. Okay, there we go. Now we actually have something different. Target sample rate, input sample rate. This probably makes sense. I'm not sure. I think we're just gonna round it as well. So for I in input as iter, is it mute iter or is it iter mute? As mute iterator? Is that not what it's called? As mute as iter. I hate it when it doesn't give me iter mutes, not as. Okay, there we go. There we go. So this should be mutable. Yeah, there we go. So what is I dot? I is equal to I ram. Mismatch types found. Okay, enumerate. What do we want? Sometimes you see this. What is this? U size. Oh, actually, I don't need to enumerate, huh? Maybe I still do, so we can do input. Hold on. Something like that. What's your problem? Cannot borrow input as mutable more than once at a time. Okay. Fair enough. First borrow occurs here at 325, and then, okay, well. That's probably not gonna work either. That's fine. We don't need to enumerate because I don't need the index. I just need the n. So, and actually, I guess if we're just going to construct a rounded version of this anyways, right? So that mute rounded output is equal to, I don't know, just empty vector, I suppose. So this needs to be a vec f64. And then rounded output dot push I round. Right, something like that. And then, because I'm not using any decimal libraries, because honestly it doesn't really matter for my use case. But we are rounding to whole values. If I wanted to be more specific, I could pull in a decimal library just for handling these. But I'm not going to, because it's not part of the bigger picture. So, okay. That should be fine, probably. Hooray, he's done it. It's good enough. So we low pass filter. It looks like it worked. I did have to change how this works. Actually, you know what? If I change this as what's your problem? Expected integer found f64. So if I do this as an i64, then that's okay. Then I doesn't need to be this. Yeah, okay, cool. It simplifies it slightly, and then this should still pass. Okay, cool. Nice. All right, hooray, tests. Down sample. All right, test down sample. I'm very scared. So down sampling happens afterwards. Okay. All right, so welcome to the squad. You guys are going to be constants. Is there a way to, whatever, target sample rate? Target cutoff, because these don't really change. So target range. There we go. That's all right. Provide a type. Okay, so this is an F64. And this is also an F64. Nice. We can get rid of these. And then target cutoff. Target range. Cool. Then target test down sample. That will also work probably the same way, because it looks like this uses just a sample rate. I suppose I don't need to pre-calculate the target cutoff and the target range, but that's fine. So given some buffer, so just assume that these work. I'm gonna use the same things here. So I just have the input. We'll run it through the same function again because these are kind of sequential. Copying the ring buffer is not necessary for me to test, I suppose. Or I guess include it here because all it does is just copy. It doesn't really matter. As in we can just assume it works. But here we are starting to get into each function is feeding data into the next one. It does kind of bother me how the API that they've went with on the right here. So here they use like an out parameter, but everything else they just use a reference. How strange. Let's see. Well, down sample. Okay. So there's two types of downsampling. So there's like... Ooh? Okay, hold on. There's, yeah, okay, since there's 2 types of downsampling, I guess we need to try all 3. So we'll do test downsample. I guess no op, basically. No op. Nope, if you will. So then we'll hit it with a downsample. The input will just be the input as slice. The output should be a new vector. So let mutable output equal, I don't know, just a new vector. Doesn't really matter what it is. And then this will just need to be passed in as a mutable reference. We'll see if this bites me in the butt later. So what's... sample rate is less than or equal to target sample rate. Okay. Output sample rate. Where is output sample rate? Okay. So we can have like, I don't know, this is like normal sample rate. F64 44100.0. So this is just the normal sample rate that most things use. Or this is like CD sample rate, yeah. CD sample rates. Remember when people used to use CDs? Those were the days. I had a few CDs. Yeah, but this should be no op, I think, because we're using a really high sample rate here. Expected in I64. Eh? Did I mess this up? Okay. So, down sample. Nope. Did not mess this up. It's just that the implementation expects integers, and I guess these automatically get casted to the appropriate value. Ooh. No. Yes. No. Oh, I've been doing it wrong. Wait a minute. Low pass filter. Wait a minute. Low pass filter. What does this expect? Ooh. Low pass filter expects... Low pass filter expects floats. Sample rate is a float. However, they've calculated their sample rates as integers, and then their cutoff and range are also integers? Huh? Who wrote this? Alright, that's okay. I can change this to just be an I60 or an F64, that's fine. I guess it doesn't make a lot of... You know what? I can see why they did it. It's because they are... I guess they're requiring a modulo on some of these. That's fine. Welcome. Welcome to the team. Okay. So what should happen is that this is no op. Nope. Because our CD sample rates are... Basically, our sample rate, our current sample rate is less than our target sample rate anyways. So the target sample rate is just like recording quality, I guess. Or our CD sample rate is less than that. So CD sample rate is 44.1K, whereas recording quality is 4.48K. So our output should be the same as our input, yeah. So we can do assert equals assert equals our output, or I guess our input should equal our output, I suppose. That's what we expect to happen. So let's run it. Please work. Hooray, he's done it. Look at that. Nice. All right, so then else if our sample rate moduloed by our target sample rate is equal to 0, when would that ever happen? So if you have like a target sample rate that's half of your, if you have a sample rate that is, or if your target sample rate is half that of your regular sample rate, then we will do a different thing. Otherwise, yeah, okay. So then this one should be test down sample 1. That's pretty much it, right? Because they are just called down sample 1 and down sample 2. Down sample 2. Also a test. So we'll grab this. This should be CD sample rate. So grab all of this. Dun, dun, and then we'll just kind of push around these things. So the CD sample rates, or hold on, this thing. Yeah, pretty much we just want all of this, right? It's just our inputs will be slightly different. So input as slice, and then if our sample rates, all right, so this is, I guess we'll just half the sample rate here, like that. Then I'll need to see what happens with the output. And I'll just tag the stuff there. Okay, so panicked, index is out of bounds. All right, so let's figure this out. At 94.9, so at here, our output, okay, so this should be a vector with capacity, this thing. So our output is here, downsample. I think this also needs to be a vector f64. And then we'll just push to it. How am I using this? So where does data come from? Data comes from here. So data will just be a new array almost always. So say goodbye. We're pushing to you. Get pushed. There we go. So that should be okay. No more array out of bounds. So now it'll just be like the values that are wrong. Nice. Okay. So on the left-hand side, oh. Oh. This will be a vector with capacity. I guess if I'm already creating the vector, I don't need to do this part anymore. So for both of these, this doesn't matter. Yeah. Wait, no. Wait, no, we do want to do this because I guess in Rust we'll always just be passing in a valid thing. Can I do this in Rust? Just pass in like an uninitialized value? Yeah, I didn't think so. I didn't think you would be able to do that. Like this should be something with capacity, but the output length is what differs. That's kind of the hard part. Yeah. Yeah, so this will just have to be an empty vector, and then we'll have to resize it, maybe? Yeah. But then why is this giving me a different amount of... Actually, no, that's totally correct, isn't it? Yeah. The output length, we resize this. Yeah, okay, that's fine. Yeah. Because the... Or maybe this would just have to be like outputs. Resize. Method requires T to implement clone. Resize with. Ooh. What does this mean? 0? It's filled. Okay, cool. Then it's simply truncated. Okay, so resize with output length, and then just fill it with zeros, I guess. So that's technically more efficient. Type thing cannot be dereferenced. So I do this. Okay. He's done it. I think that's okay. That's like a slight optimization that doesn't really help, but I guess it makes sense. Okay, hold on. So what does resize do? So new length, where resizes the vector in place so the length is equal to the new length. Yeah. So it was equal to size who? I'm thinking. I'm thinking. This doesn't seem quite right. With capacity. Am I doing this wrong then? So in algorithm here, downsample 1, it's I is less than output length. So this is exclusive to the output length. So this should be output length minus 1. So wait. Oh, I'm pushing. Ah. I guess that's okay. Right? So if we resize it to this length and then we fill it... Oh, because this is filling it with zeros. I guess that's okay. Then we can change this back to like a mutable slice or whatever we want it to be. Right, like that should still be okay. And then similarly for this, we'll do the same thing actually. It's pretty much the same. So we'll fill it with zeros, since we already have to create something here. Yeah, I think that's kind of unique for this one. Everything else just uses, it doesn't create a new array, yeah. But it's only for this one that we need to resize it because we are limiting the amount of samples. Yeah. So we're probably truncating it, but we also need to account for the fact that we might just have empty values. I think that makes sense. I guess, yeah, that's probably okay. That's probably okay. It's a bit different from how they did it, though. So then this should still fail, but then it'll be exactly what I'm expecting, which is just one value. Okay. And technically it's more memory efficient, so hooray. Yeah, and I guess it'll always be truncated in this case anyways, right? Because if the sample rate is less than the target sample rate, then we just copy it. So that's okay. I suppose this should be append, right? When this wants it, you would want to do... What do you got? Nope. What are the vector... Please, I just want... Code completion. Okay, how do I append a vector to you? So... Initialize... Okay, vec extend. Something like that. So that'll be okay. So test down sample 1. This is no sample, or test down sample no op. Okay, I'm back. Oh, welcome back. Welcome back. I am, I guess, technically enhancing it. It's technically being enhanced, maybe. So I think in this case, making a few small changes. This is still going to... No ops should still work, no problems. Downsample 1, I guess it is truncating it, so now we'll just need to compare these two values. And by compare these two values, I mean... it'll be... Did that extend work? Yeah, it did, yeah. I don't think you needed the 2vec. I think I do. Maybe I don't. Isn't it because it's a reference to a slice that I need to do a thing? Is that not it? Remove it. Oh, okay, well we can try to remove it. I don't know. See what the compiler thinks about it. Yeah, maybe. Yeah. So no, that's downsample 1. That's gonna fail. No op. Yeah. Let's try that again. Okay, cool. Neat. Because how the original C# code works is that they just pass in an uninitialized value. But I think in Rust's case, I can't do that. So I'll always be passing in empty vectors anyways. The 2vec just made a clone for no reason. Yeah. So I think in Rust, this is what I have to do. Can't do the C# thing of just passing in nulls, which is a good thing, I think. Maybe. If there was a better way of doing it, right? Because like that output is a new value, right? So I'm not sure how you would pass in nothing. Right, because this will always be the output whenever I actually use this in the actual job, right? What do you mean nothing? Yeah, so we'll see here in the actual implementation, this is what the output will be. So they just initialize it as nothing. So that it just has a type and it's a null pointer. But then they pass it into the downsample function. And then in their implementation, they just create a new array on the spot for each of these outputs. Yeah, just use vec. Yeah, that's what I'm thinking. That's the change between Rust and C#. So I think naively it would still work if I did it the same way, but I think this is like just a very simple optimization in my case. But here I need to do I guess it'll be vec, one of these. Then I'm gonna grab, where is it? Give me the error. Did not compile. Okay, hold on. I don't think it would work if you removed it. Well, yeah, it didn't work, yeah. But I was wondering if there was a way for me to pass in a null pointer. So I can more stringently follow the C# implementation, but that's probably not a good idea. Oh, hold on. Yeah, just use unsafe. Oh, baby. Don't tempt me. I might do it. Alright. So there's downsample 1. I think we always want to tag it to this, and it should be deterministic what happens. Alright, cool. And so this is sample rate divided by 2, and then this is just lower sample rate for whatever reason. So we can do like target sample, or this is like recording sample, I guess. So target sample rate, let's change all occurrences. This is like recording sample rate. I think that's okay. Then here in test downsample 2, low pass filter. What does low pass filter do? Output sample rate. Recording sample rate. Something like that. And then the recording sample rate is higher than the CD sample rate, which means that we won't hit this condition. We should actually hit this final condition. Yeah. Okay, so then let's see what we get. This is not the best way of testing, for sure. Let's see. 1 passed, so that's not good. That shouldn't have passed. Down sample. That shouldn't have passed. Did it just hit this function? I don't have a debugger working for whatever reason, so we're just gonna do the Python thing. So which one did we hit? So it actually just copied it. I think that's what happened. Interesting. Interesting. Yeah? And then we run no op. Then we should see the ASDF. Yeah, okay. What does downsample 2 do? Because it gave me the same input as my output. So for J in 0 to output length, I don't know what this means. I guess, wait a minute, hold on. That's not right. So if your sample rate is less than or equal to... Oh, it's this one's wrong. Okay, hold on. Oh my god. I messed something up, hold on. Undo me. Undo me. Okay. That's why it was kind of broken. So this should still work. 1 passed. This needs to be changed from target sample rate to just regular, like I guess recording sample rate. So this is recording sample rate. Can't use the VS Code find and replace because that just broke everything. Very nice. Then this is recording sample rates, and then this will just be CD sample rate. That's why it broke. Okay, cool. And then we'll just compare input to output. And then we'll figure out what we actually need to test here. That'll be exciting. So 1 passed still. That's unfortunate. Why? Why is this so? What if our what if our sample rate is 2 times the size? What happens then? Okay, good. So nothing happened. It should also not be divisible by... it should not be moduloed. So we shouldn't be hitting downsample 1. I suppose I should... What I should do is actually call down downsample 1 and downsample 2 individually to test those, but those are just kind of helper functions, so it doesn't matter, in my opinion. I guess that's okay. Hit it with a very cheeky print line really quick. Let's see. Yeah, there it is. Yeah, I mean, it called it. Yeah. I don't know what df is. Output length, that makes sense. We do all of this. And then I have no idea what this is doing. I guess that's okay. And I want to try to avoid rounding errors, so I'm just gonna do this. I guess that's okay, right? And then this will pass, yeah. That doesn't seem right, so let's add a to-do. To-do, this doesn't seem correct. Yep, that's for sure. Pre-emphasis. What is pre-emphasis? So they call it with a 0.97 F based off of whatever they're doing with the downsample. So test pre-emphasis. And so we'll just, I'm gonna grab downsample no op, because that's just easy. And that guarantees me to have a decent amount of data at the very least. And then they call it with 0.97. So, pre-emphasis. So this will be output as mutable slice. And then this one is going to be 0.97. And so I can guarantee that data will be populated here, for sure. Yeah. Yeah. And then we'll just assert equals. I don't know. Output equals input. Hopefully that's not true. If it is true, then that means nothing's happening. Okay, good. So the values have changed slightly, but only for indices 1 and 2. Oh, putting pants on. It's starting to get cold again. The temperature is dropping. Heater doesn't work. All right. I think the person below me has moved out for the winter because they're presumably students, so they're not running their heater, which I've been making good use of. I miss having my floors be kind of warm. All right, so what we can do here is let rounded outputs equal outputs, I guess, round. How do I do? Isn't it possible to stream in output like that? I forget. I think I had something here that was trying to do that. No, maybe not. Yeah, isn't it? Is it map? Or is it actually just called stream? It's not called stream. What is it called? Like, I want to convert all things in a vector to, I want to round every single value in the vector. Yeah. So, this is my output vector. Filled with F64s. I want to round them all. Oh, iter mute. Is it really it? Then what? And then what? Isn't there a map function I can use? Like map some value x round. That's what I want. But I'm pretty sure that syntax doesn't work. Actually, did that syntax totally work? It might have. No, that's your iter mute, right? Use a for loop. I don't want to loop. I know how to do this in Java. Don't be like this. And the idiomatic solution would be we use a for loop. I think, yeah, probably. All right. I'll accept this for now. I will let it be known I'm not happy with it. What am I doing? All right. For I in. Wait, do you want to mutate in place or create a new list? I guess either one is fine, right? Either one is fine. I don't really care, honestly. We can just do this though. This is the easiest way to do it for sure. I think I've already done this once. So in place is loop. Otherwise use map collect. Oh, okay, yeah. I knew there was a way to do that. Oh yeah, in Java, yeah. Java 2 you also need to collect at the end of it. My bad. Yeah, there we go. What's your problem now? Type annotations. Sure. This is a vector of F64s. Thank you, thank you. I knew there was a way to do it. Try using F64 round. Ooh. In which part? This part's readable to me. But where would I round it? Set the as the argument to map. As the argument? F64 round? Is that all you would do? That doesn't make sense to me. No. Expected unit structure. What? Dude, replace the closure. F64. Round. Probably take out the function thing because now we're just passing in a type mismatch and is that right? Hold on, I can figure this out. Map. That sucks. Oh, okay. Am I missing something or am I not? Where is map over here? Map. From the map. Maybe not. It won't work. All right, well. It's okay. I'm more familiar with this function thing anyways. Change iter mutes into iter. Okay. F64 is equal to outputs into iter. Probably map. Actually, there's a few map functions, aren't there? And then this would be like F64 map. One of these, or you don't need to do that. I don't think you need to do that. The trait bounds were not satisfied. Not map. Oh, right, yeah, round. I knew that. Oh, okay. Yeah, look at that. What's the difference between into iter and intermute? Iter-mute. Creates an iterator from a value. Returns an iterator that allows modifying each value. Creates an iterator from a value. What? What? Self into iter. How confusing, but that's okay. Anyways, I mean, this is what we're doing though, which is creating a new vector of, just going to grab these things, 9970. We're tagging it to these values basically. 28896. Actually, well, I don't think reading the book would have helped me there. No, that's just like a syntax thing I need to learn. The difference between these two things, that's just like a naming thing, naming collision in my brain. That will never ever be resolved until I use it enough to internalize it. Anyways, check this out. Okay, well. Oh, did I do it to the wrong values? Wait a minute. No? Maybe? Hold on. Assert equals, so just our raw output against our raw input. Hold on. Assert equals, what's your problem? Oh, okay. That's fine. Send me again, that's okay. We won't wait for the compiler. Now the value is wrong, which is good. So our output is 9. Oh, I did it as the wrong stuff. Okay, so that should be 964648. Yeah, I think this is one of the things you should be saying for shame on, for sure. Is the fact that I'm not using a decimal library to do all the mapping for me. Instead, I'm just comparing it against rounded values. Still failed, huh? What happened? Oh, don't tell me. Oh, okay, wait. I just typed it wrong. That's fine. Or is this not deterministic? Let's run it again. Oh, and check this out, Knock. I was telling you before that I was banging my head against our flaky tests. I found the answer. Well, I found part of the answer, which is that our social security numbers, or the test, the fake social security numbers we're passing in for testing, we're causing collisions in the actual API. So, and the reason, and that's part of that, and that's the reason why the tests were like failing at random, is because we're generating random SSNs and then not deleting them. So technically, right, a social security number has 1, 2, 3, 4, 5, 6, 10 values in it. And so we're auto-generating 6 of them because it is possible to generate an invalid social security number like that. So like this is the minimum valid social security number, 100, 100, 1000. So whatever 10 to the power of 6 is like that's the, I guess that's the barrier to random generation. And so I guess the amusing part is that we had so much garbage in the database that we were actually sometimes generating a duplicate social security number. I don't know how that's possible for like multiple people to generate the same garbage social security number within this frame, but it was happening, and it was happening a lot. Actually, what is 10 to the power of 6? How many numbers is that? Calculator. 10 to the power of 6. Oh, that's actually only 1 million. That's actually not, that's not bad. considering that we have 15,000 test accounts. Or I guess 15,000 preloaded test accounts, and then during the test we generate like 1,000 more temporary ones, but then we also have one-off test accounts. Actually, yeah, never mind. I'm crazy. I don't know what I'm talking about. That's only 1 million. Anyways, that was only part of the problem. The second part of the problem is that the time zone difference. I was 6 hours off in one of my calculations. So the API would respond correctly for 18 hours, and then there was just like a 6-hour period of the day where they would just be completely wrong. Which is somewhat amusing. Somewhat amusing. That's also been fixed. And then there's also just like random API failures because it's a combination, like end-to-end test, or I guess not end-to-end test, but it's like a combination like BDD plus integration test. At least you figured it out? Yeah, well, I think there's still a few things that are breaking, but it fails a lot less frequently now, at least. It fails a lot less frequently now. And I think what I was going to do actually was going to try to git bisect just like the entire test suite. That would be a little painful, not gonna lie. Because in order to run the entire test suite, we have to deploy a local Kubernetes cluster, which takes forever, takes about 30 minutes. So if I git bisected it, it would, I would be able to run 2 tests per hour pretty much over the period of about a month. So that would be fun. Luckily, I didn't have to do that. All right, we're gonna reuse all this. So this is hamming window. Do love me some ham. Oh, is this not gonna work, by the way? Because we're already borrowing it once. Oh, okay, no, that's fine. Nice. So actually, what does this do? So if I was doing this not as a slice, but as like an actual vector I was passing into each of these functions, wouldn't that mean I would run into the kind of a lifetime issue, wouldn't I? But since I'm actually accepting slices, which are just views into a vector, we don't run into that lifetime or the borrow issue. Is this correct? I think that's correct. So actually, check it out. He's done it. So what are we checking for here, though? I have no idea. Let's compare. Let's compare output to input. Assert equals output, input. So this is going to be wrong, but that's fine. Hit me with it. So our output is 798, so we need to round again. So I refuse to use a decimal library. And then this is going to be vec of... Alright, I'm gonna head off now. Alright, thanks for hanging around, Knock. Catch you later. Thanks for tuning in as always, and your help is always appreciated. Maybe I will have read the book at one point. I can read the book? No. Reading's for nerds. We don't read here. Who needs to read when I have Twitch chat? Alright, there we go. Pre-hamming, that's fine. We're almost done. Yeah. I guess there's only, there's FFT, which is... I guess that's okay. We're just kind of building up more and more data as the farther we go down. Test FFT. Right, slap all this into here. Then let mutable spectrum equal, so this needs to be a vec of F64s. This is an empty vec, how nice. Then FFT, that takes output as slice, and then we'll just pass in spectrum. Yeah, spectrum. A mutable reference to spectrum. Actually, wait a minute. Wait a minute. Who? If we're just going to do this, yeah, actually I don't need to do that then. Yeah, we can just assume that it's created. Yeah. I don't need to assign to it. It'll always be here. Then we can do assert equals spectrum to input. So then we'll run it, see what the error value is, and then just tag it to that. Okay, index out of bounds, 140. So spectrum re with capacity. With capacity. So this is just, I think we can just push here. So push dot push. Yeah. Yeah. Yes. Probably. I'm a little confused, but I think that's okay. Or I wonder if I should actually, like, I should zero these out. So fill these, yeah, I feel like I should actually fill these with empty data instead of just, yeah, I think I should actually fill these with empty data. So this is now with capacity n, sure, but then this will be vec and fill it with zeros n times, right? And then, ooh, okay, hold on. As mutable slice, ooh, oh, because it's a bunch of integers, right? So we can assume, make it assume that these will be correct as well, boom. Which means I think I should also be consistent with how I'm handling some of these other things. So one of these, outputs, push, that's fine. Let's, I don't know what I'm doing. That's okay, I think. Run the test again. That's probably okay. What happened? Panic 163. So this one, okay. So let's do that mute even re equal vec 0, 0 with capacity n divided by 2 as u size, and then all of these need to be adjusted to fit this format. So mute even im equals this. Yeah, that's the same. This one is slightly different. Actually, is this slightly different? Oh, no, these are all the same. Yeah, mute odd re. And then this one is let mute odd im. That's probably fine. Yeah. Give it another test. We'll just run it again. That's good. Panic 147. Okay, so we've now passed this function, which is good. 147 spectrum. So panicked at index out of bounds. The length is 0, but the index is 0. Huh? What do you mean? 147.9. Yeah. Okay. Spectrum. Did I not pass in... Oh, okay. So this needs to be resized to the appropriate whatever it needs to be. So, let me see. FFT, what did you do? Okay, so I need to resize the spectrum according to whatever n is supposed to be, which is the input. I suppose, like, I could just do this, which is... That's one of the optimization. That's an optimization we can do later. Spectrum, resize. New length, n, as you size. Actually, just n. Value, zeros. Yeah, that should be fine. Yeah. Like, it would be better to do it here, I think. Well, maybe not. I don't know. That's something I'm still on the fence about. It's like, how much logic should the functions be doing as opposed to, like, I guess just the data that, how much data cleaning should you be doing? It's always something, that's a design decision, I think. Or where does the cleaning of the data occur? So we're gonna do this. Let rounded spectrum equal this thing. Spectrum. So this needs to be a vec of f64s. Then rounded spectrum is equal to a new vec of, let me see, this is 10, 4, 4, 6, 0. 8850 and then 8120. Yeah, that should be okay. Run the test. Okay, cool. Does this make sense? I have no idea. But it's done. We're almost done testing all of these as well. So that's exciting. Test Mel filter bank. So what does Mel filter bank do? Mel spectrum does a thing, and then it does a thing with the Mel spectrum. Okay, so these all kind of build off of each other. Okay, cool. So let's do all of this. It's making it also very difficult for me to reuse things. What if I did this? Can a test return anything? So it returns a vec f64. Yeah, I didn't think so. Main has an invalid return type. Yeah, unfortunate. It's okay. Let mutable Mel spectrum equal just a new vector. Make it explicit, and then we'll hit it with Mel filter bank. So this is the spectrum as slice. Then Mel spectrum would be a mutable Mel spectrum. Sample rates, target sample rates. So let's say it's going to be CD sample rate. Oh geez. And then Mel div. Mel filter bank channels. I don't know. Mel filter bank channels. What do you got for me? So this is something that's created here. Mel filter bank channels. I still don't know what that means. Profile. When did we create the profile? Mel filter bank. Ooh. Mel filter bank channels. Yeah. When do we create Mel filter bank channels? Like, this is a struct, I think. Profile. When is this created? Profile. Phonemes and profile. Why don't you have anything? Mel filter bank channels. When is this created? Or maybe this is created like in the editor. So if I look inside of lip sync editor, so editor, profile editor, this might give me a default value. Mel filter. We're looking for Mel filter bank channels. Beautiful. So it needs to be between 12 and 48. All right. Between 12 and 48. Let's give it, I don't know, 24. That feels pretty good. Defined as 12 to 48 in the Unity impl. Okay. And then we'll just hit it with an assert equals again. So this will be the Mel spectrum against our input, and then we'll just see what it gives us. So make this a test. Run the test, and then, okay. Did I forget to, yeah, okay. Ooh. I should be okay. So what happened? Index out of bounds, 228. So at 228, okay. I think this one needs to be Mel spectrum resize. So then this is Mel div, and then just a bunch of zeros. And then Mel div as usize. Yeah. So no need to actually access the pointer. I think this should just work. Yeah. Oh no. It zeroed everything out. That's not good. What happened? What happened? What happened? What happened? So this is the Mel spectrum. Yep. This is actually just I, right? Hey. Some sort of index, IDX. Ooh. Wait a minute. What is this? That's an I64? Oh, then I need that as an, okay, so I as usize, sure. I don't think this will make a difference though. Yeah, it's all just, it's completely zeroed out. So what does this mean? What does this mean when it's completely zeroed out? If I pass in like a, like what are they passing in? They're passing in like a target, yeah, they're just using their target sample rate. Do I not have enough things to, you know what? I probably don't have enough things to even process here, right? That might be it, like because this requires 3 values at the very least, it looks like. Nope, okay, that wasn't it. I tried. I have a feeling it has to do with this value here, like the target sample rate. What if we just multiply this by 2? Try that on for size. See how it feels. I feel like a bunch of zeros is not correct. I feel like something that's just a bunch of zeros is not correct. So let's take a look at the algorithm and see what I'm doing wrong here. There must be something that's wrong. So we resize the MEL spectrum to just whatever this is, which is the MEL. Just resize it to the MEL div, right? MEL filter bank. Yeah, there. Then we have our Fmax, a bunch of values, then MEL spectrum is equal to this value, equal to the sum. All right, so it must be something here that we're not summing them properly. Maybe I can just print this out really quick. Just give it a really quick cheeky print. Oh, okay. So we're not even hitting sum. Interesting. Who needs debuggers when you just have print statements? Enter first 4. All right. So we've entered, yeah, so we successfully entered the for loop. That's fine. I don't care. And then here, I'm interested to see if we ever hit any of these. So we don't. We never hit this. So that makes sense. Why is this not working? So this is I begin plus 1 to the end. Huh. Did I do my math wrong? So this is what is the I begin, I guess? Print I begin. Print line. Excited print line. Send it. No, that's right. It must be like the I end must be wrong then. Right? And then this is the end of it. I have still yet to set up the actual debugger. Okay, yeah. So these are the same values pretty much entirely. And then especially this part, yeah. Is it because there's not enough values here for me to actually do this properly? So do I need to pass in just more things? So I can just duplicate this thing here. So it's just like a big vector of things. Yeah, it might be because the vector's not big enough. Like there's not enough values for me to do anything. Yeah, like now I'm actually getting enough values to do stuff with it. Yeah, you know what? It's probably because I don't have enough values. So let's just input like a weird square wave here. Have fun. Some of these are nan. That's good. Some of these are nan, so if you just input a square wave, it might not work as expected. These are all nan now. Or actually, not a number? Is that what it says? No, not... Yeah, is that not a number? Is that it? Bring me back. I'm interested. That's a bit weird. So why do I get nan sometimes? Begin and sometimes it just nans itself? Because the input is nan as well? Not a number? I don't really understand. It must be the calculation that's off then. Perhaps. Oh, you know what? Is it because of this? Oh, hello, Samzir. Hello. How are you doing today? Back at it again with the Rust stuff. Slowly losing my mind. Mostly because I don't understand what this is supposed to do. And they don't have any tests included in their C# solution. So I'm just trying to figure out... I'm just trying to nail down like specific values. Because I'm slowly fixing some bugs in the initial algorithm as well. I think this one's a pretty big one because I'm just getting a bunch of zeros. So that's telling me that I'm doing something wrong. Not the mind. It's alright. Lost our minds before. We can lose it again. So I'm wondering. I'm looking at it. Ignore the print statements. I don't have my debugger set up. I'm doing it Python style. Which is actually something I've had to do like in bigger projects as well, but that was in Java, when I was doing more Java. Because actually, I think it was like we were doing development on a Spring Boot thing, but the computer I was assigned to use, or I guess the virtual desktop I was assigned to use, didn't have enough RAM to run the application and a debugger at the same time. So I just had to look at the logs and add print statements. Those are fun days. Good times. So I'm very used to just adding print statements and waiting. Something doesn't seem right here. So these 4 loops are correct. But something about, I think it's something that has to do with like the test data I'm passing in must be wrong. Something about the test data I'm passing in must be wrong. Or is it this? Is it this? Is it like the values I'm passing in here are incorrect? Hit it with the print line. Hey, one of these. Got pinged on my phone. Oh, it's just Duolingo. I don't care about Duolingo. He says as he's, I think I'm on like a 500 something streak in Duolingo, which is pretty good considering that am doing 2 languages in that. Let me think. Oh, you know what? Is it this? This is casting I as an F64, as F64. Then what is I center? I wonder if I should cast these as F64s beforehand. Well, they're both integers, but they'll lose precision before they actually do anything, I think. Around assigned value, yeah, that's fine. And then similarly for this one, these should all be casted to F64s beforehand. Otherwise, I'll lose the precision, right? Because they're integers. Something like that. I mean, I don't know. I'm grasping at straws. We're just printing a bunch of things as well. No. Okay. I am a little confused as to why I'm getting not a number sometimes. So, where does it turn into not a number? It must be in FFT, right? So if I do like a print line, something, spectrum probably, and then that's gonna give me, doesn't implement display. We can try to use this thing. Yeah, okay, well, give it a try. So what happened in FFT? Kind of go all the way up. Okay, so some of these get pushed into not a number if you pass too many values into it. Interesting. Interesting. So technically, like, any number I pass in should be valid. So that's a bit concerning that sometimes I just get not a number. I suppose I should have tested with more than 3 values. But yeah, NaN is not a number in Rust, right? Rust, NaN. NaN. NaN in standard F64. Not a number, use F64 NaN instead. Alright, yeah, not a number. So what? What is not a number? For mathematical operations are meaningless. Does it make more sense to return not a number or none? NaN is a historical accident. It should be avoided in almost all cases. When you need it, you'll know it. What is NaN? What is NaN used for? What is NaN used for? NaN, on the other hand, really has no place in software. It's not a number and really shouldn't be a value for a numeric type. It exists because it's implemented in hardware, and hardware cannot be in an invalid state, so it has to have a way of representing failed computations. Software doesn't, as it can just crash when a computation fails. Calculation returns NaN. You have to deal with it after you've already spent process time. Blah, blah, blah. That's 6 years ago. What is NaN? I don't understand what NaN is for. Okay, Stack Overflow. This is Rust. Yeah, it looks like a Rust. How do I sort NaN so it's greater than any other number and equal to any other NaN? I don't know. Is not a number. Why am I getting not a number sometimes then? So looking at this, we have a position or index 2, 3, 5. So why specifically these are we getting not a number? Are they because they're repeated? Not a number. That's something I've never encountered before. Give me the Stack Overflow, I don't know. Yeah. I don't understand how do I use this? Not a number. Not a number. Yeah. Yeah, I'm not sure. Not a number, dude. Not a number. Is it? It must be coming from here, though, right? Yeah. So whatever this calculation is, we're just getting not a number. Spectrum re is equal to data, then spectrum m. Spectrum m. Wait a minute. What? Wait a minute. What? So FFT then sends itself back in, then spectrum m. Wait a minute. This looks wrong. Why did I do this? Why did I do this? Oh, these need to be whatever I calculated n to be. So then maybe that should work. I don't know. That's interesting though. It's interesting. Still getting pretty good amount of nans. Yeah, I think there have been some typos, I think. There were some typos and that's kind of screwing me. So here, we calculate all of these things, and then I also calculate a cx, cy, and then construct a float 2 from that. -2 float times pi times I as an f64 divided by n as an f64. These are all using I. What is n? What are you using big N for? Big N. Big N is just whatever was passed to this function. N is just a U size. So it's a U size, and then we just constantly divide it by 2. Really? Okay. And then pretty much everything should be using, yes. Everything should be using I in that case, besides this plus I. That isn't, this does not compute. Did that change how test at FFT works? No? I think this test is probably bad because it doesn't work for large amounts of numbers. Actually, are these the same values as calculated up here? No, they're different, which is good, but only by a little. But once you start getting up to higher numbers or higher amounts of numbers, which is probably what I'm going to have to deal with, this kind of breaks down because now we just have not a number passed in for whatever reason. So looking at the FFT implementation, FFT, where is it? Where are you? Or it's not FFT, it's this one, the mouth filter bank. So we run through, so whenever we hit ASDF, we either print out a 0, or no, 0 and then not a number. Presumably because the thing we're comparing against is also not a number. So if I look at the, let's look at the, like the spectrum and see what happens. Yeah, that's easy enough, right? They'll be not equal anyways. So let's see, the right side has a few not a numbers, but there's a lot less now. I think there's still a problem with my ports. That's the most likely thing that's happening. So here, in FFT, boom, boom, boom. Okay, so boom, boom. We want to resize it to whatever the length of our data is. Yep. Then we create this also sized appropriately to our data length. Then we fill it with the data, which we're going to keep that for now. Not necessarily a bad thing, I think. And then we call FFT, then I 0 to n length of the float 2. So these are not a number. Okay, hold on. Let's hit this with a print line. So im re, and then I guess m and re. See how that feels. Try that on for size. So we are working with a few not a numbers. And then taking the absolute value. Why am I getting not a number? And like a lot of this is happening in the FFT step. So it must be Is it just in the spectrum? Yeah, no. Is it happening before the spectrum? So if I hit it with like a print line here. So I just try to look at the output. I'm interested to see what this looks like. When do I start getting not a number? I should probably write a test for that. There's one not a number from hamming window. I believed in you, Ham. You have failed me for probably not the last time. You can still continue to fail me a few times. All right, so pre-emphasis also has an error in it. Let's see, does downsample have an error in it? I guess it's like the not a number is just propagating. Yeah, not in town rumors, yeah. It's just the one not a number that poisons the rest of them. That's so weird. That is bizarre. Good thing I caught this here. Yeah, there we go. Yeah. Actually, what the heck? Wait a minute. There's our inputs. Nothing happens between low pass filter and downsample. So downsample. I guess these should actually be reversed if I want anything to happen. But it is interesting that low pass filter is returning not a number sometimes. So hold on. What's happening in low pass filter? That's the problem. So it's like the last number is just invalid in low pass filter. So let's look at my low pass filter implementation. So, or their low pass filter implementation. LP, by the way. Try it one more time. So it gets poisoned here, probably, right? LP, yeah. So what happens? So cutoff is the cutoff sample rate, yep. Then we have a temp thing, which is just the data to vec. It's just a clone. We have an integer n. Should be an integer. There's no way that this is the cause of it, right? That might be the cause of it. I really hope it's not. It could be. So we do all of this, and then we create a mutable b with capacity this. And then we are pushing to it appropriately, so low pass filter. So it takes in just b, right? So here, for I is equal to 0 to n, which is the b length. Right, b length. What is b length? B len n. Yeah, n is b len, so we can just reuse n, right? So 0 to n, I plus plus, yeah, that's implicit. Then let x, which is some sort of f64, be equal to I minus n, which is blen, minus 1 as an f64 divided by 2. So this is an f64. That's correct. Let angle be 2 times pi times cutoff times x, which is this calculation here, and then we just push it onto it. Wait a minute. Is this it? Did I find it? I think I found it. Wait a minute. Wait a minute. I think I found it. Okay. Let mut be equal to a vec new. What was the syntax? This n as usize? Or is it the other way around? How do you create a new vector with a given size? It was that, right? Yeah. So fill it with zeros this many times. And so here we want to do I is equal to all of this, and then I as usize. That might be it. No, okay, well, I tried. I tried. Why is the last one not a number? Why is the last one not a number? Why is the last one not a number? That doesn't make any sense to me. So let's switch this up. No, because that has to be a U size. Or no, this has to be an I... hold on. Hold on. N as an I64 minus 1. N. That's an I64. Yeah. No, that's fine. Right? This doesn't make any... That doesn't make a difference. Try changing the order of let angle. Sometimes floating point multiplication cares about order. Okay, well. Let angle... Well, I mean, this is exactly what they have, right? So they have 2 times math pi times cutoff times x. So I'm not sure where it would be wrong. Or I guess like what the optimal thing would be at this point. Because that looks right to me, right? Like how would you flip those around so it would make more sense? Because it's just a bunch of multiplication on this line. Let angle. Probably is what I've seen in the past. Oh no. Well, I don't know. Like what would you suggest then? I'm not seeing anything that really jumps out at me. I guess I would be, or I guess x might be a less than 1. Move pi to the end. I really hope it's not that. That would be absolutely horrible if that was the case. It's possible, yeah. I mean, who knows, right? I'm just looking for no nans. Yeah, there's the nan. Not a number. I don't think that's it. I think that's highly unlikely. I am kind of wondering what this is. Or it's probably this part, huh? Like I don't need to mess with this. This looks correct at this point. It's probably this part because data is the output thing. Oh. Wait, no, that's okay. Low pass filter. Low pass filter. I pass in. Low pass filter always needs to be given a mutable vector, which means that this will always have a valid length. There must be something here with this I that's incorrect. If data I is nan, I don't know, it just hit me with a print line. And found the nan. And then give me some data on what exactly it was, I suppose. So this would be... This would be I. You know what? Give me a little bit of formatting here. There's the BJ. Not weird, by the way. And then there is the temp. So that will be pass in the I, pass in BJ, and then temp I minus J. You know what? I also need to check J. Maybe J is incorrect. It has something to do with these numbers here. So we're just gonna look at them. You know, professional programmer, by the way. Just uses a bunch of print lines. Do the calculations. Okay, so BJ is a nan. Oh, now we're... Okay, actually, then it has to be this one, right? Why is this nan? So at I11, then J11 as well. So on just the last value, I'm assuming. So this is presumably 1, 2, 3, 4, 5, 6, 7. 7, 7, 7, 8, 9, 10, 11, 12. So this is 11. So on the last value, we calculate something incorrect. So it's something in this line here. Interesting. Interesting. So let's move this print line here. And also, I guess what we can do is, if it is nan, then we'll just do data I is equal to, we'll just zero it out for whatever reason, I guess. Let's add it to do. This should never happen, question mark. Maybe remove later. Interesting. This part, let's check this. And I need to see what the values we calculate here are. So if this is nan, then we'll hit it with a print line. I feel bad, but you know, sacrifices have to be made sometimes. So let's get the I value. Let's get the X value. Let's get the ang value. And I suppose we already know what the current value is, right? So then I, X, ang. Sick. So which one of these? Is one of these a nan? Alright, so I is 11, X is 0, angle's 0. Oh! Oh. We divided by 0. We divided by 0. That's why. We divided by 0. Well, I don't know. I guess we'll just check for nan. Or oh, you know what? We can check for if angle is, yeah, we'll just do an angle check, right? So if ang is less than or equal is equal to just 0, right? Or is not equal to 0. Then we'll do whatever the heck this is. Otherwise, actually, does Rust have a ternary operator? Rust ternary operator. Ternary. I guess not. Is equal to, we'll just zero it out, I suppose. So that's okay. He's done it. Then we don't need to have this check here. Make sure we remove all the other print lines. Just run through. You can expression the if. Nah. Oh, yeah, I could, right? That's something I don't do nearly enough because those other things don't have it. Where was that? That was in here. So it's like if let v equal, or it lets, okay, hold on, I've done this wrong. I was thinking of the wrong if. So let's v equal, is that true? Can you do that? I don't know. That sounds complicated. Let's just leave it like this. I know this will probably work. I don't. Oh, okay, we panicked, so that's good. Oh no, left doesn't equal right. Yeah, that's correct. by moving the b equals to the front of the if. Oh. Wait a minute. What would that look like then? Okay, hold on. We can do this. We already have the book open, so. Yeah, that's the basic control flow. Falsy, truthy, blah, blah. And let number if. Okay, cool. Let's bi as usize equal if ang is not equal 0, then slap this in there. Else, I guess that's more or less like a really verbose ternary operator, huh? Yeah, okay. Oh. I guess you don't need the let. Yeah. Yeah, okay, cool. I guess that's shorter? Yeah? Very nice. Alright. We'll run it again. We haven't really changed anything, but why I this is the part that's kind of boggling my mind, is why are these, when it's short enough it also gets formatted on one line? Yeah. So I guess it's equivalent to a ternary operator. Whereas I don't guess, I know it's equivalence. Which is nice, I'm okay with that. But this is the problem with this part, where it's like I don't understand what a mel filter bank is supposed to do. Mel filter bank, sure. How do you obtain a mel filter bank? Sure. You can find a really nice tutorial. In general, use mel filter banks for two main reasons. Aims to mimic nonlinear human ear perception of sound. Human ears are more discriminative at lower frequencies and less discriminative at higher frequencies. Mel filter banks do exactly that by giving better resolution at low frequencies and less at high. Triangular filter banks help capture the energy at each critical frequency band and roughly approximates the spectrum shape. This also helps to smooth the harmonic structure. Python. Pre-emphasis. Window. Oh, that's what it is. Yeah. I guess that makes sense. Yeah, it's transforming it so it's just more bass, more receptive to bass, I suppose. That's what I'm kind of gathering from it. Okay, so that's not the calculation I'm using, but I think this would have been really useful to see beforehand. Now this is now this I can get behind. I do a lot of Python. Left, center, right. Yeah, that matches up with what I have been seeing as well with the mel filter bank here. So your mels. So you have your melodic begin, center, end, then you have your floats begin, center, end, and then we convert it once again to I begin, center, end. Ooh. Interesting. Mel frequency, cepstral coefficients. This is getting very scary. Oh, geez. Now we're using everything here. And there's the DCT function that I've also implemented. Do you have any data that I can take? Is this what NumPy, floor, NFFT? Those are hot right now. Hertz points, sample rates. What is bin? What are you? Or what is NFFT? Is this just something that you have? Endpoints. Oh, endpoint for your transform. NFFT is usually 512 question mark? Yeah, maybe. That's okay. No. How are you generating random data? That's what I want to know. I would like to use your algorithm to generate garbage. So this zeroes it out. Oh man, that's tough. I don't know what I'm looking at. There's too much audio jargon. Yeah, these are your hertz. What is bin? NumPy floor. Okay, so what does NumPy floor do? I don't usually use NumPy. I don't do data science. Maybe I should get into data science. But NumPy floor. Does this give you like a bunch of things? Is that what it does? What does this return? Returns the floor of the inputs element wise. So these are all the... These aren't arrays though. Are these arrays? Which one of these is an... Oh, hertz points is an array. No, wait, no, that's not. No, this is just a single number. Huh? The NumPy 0? Where's 0? Give me 0. Why isn't this, It's not alphabetical. Who wrote this? 0. Let's see if I can just find it here. Alright, that's really cool. NumPy. Man, I'm learning a lot. Can tell you that for sure. Okay, so this is an array. Okay, this is an array creation thing. Returns a new array of given shape and type filled with zeros. Yep, I can do that. Are they modifying these values? Is that what's happening? So it takes a tuple, sure. So this is an int or tuple of ints, and then it's just a bunch of zeros though. How are you? Hey? fbank. So fbank is initialized as presumably one of these. It's a two-dimensional, probably maybe a three-dimensional array. I'm not sure, but it's all zeros. Then in Python, whenever you assign, that's when you allocate a new variable. So f minus fm. Wait, that doesn't make any sense though. Ooh. Because these should be zeroed out. Bin shouldn't even be an array. This should just be a number. Ooh. What does NumPy floor gives you? The floor of the input element wise. Ooh. Oh, it's an array. This is an array? Which one of these is an array? Mel points? Is mel points? Oh, this is an array. Oh. And a floor is all the values. Oh, okay. So what is NumPy linspace? Linear space. Okay, cool. So then looking at this, I can probably generate some garbage using roughly the same API. So return evenly spaced numbers over a specified interval. Okay. Evenly spaced in the mel scale. So they're not using any of these parameter names, so they're just doing it in order. So start, stop, and then the number is nfilt plus 2. Evenly spaced numbers over a specified interval. I mean, that's pretty much what I have here, right? These are evenly spaced. Well, these are numbers over an interval, so it shouldn't matter. I guess we can switch them up just to have some variation, so they're not all the same. I highly doubt that makes a huge difference, though. If that does make a huge difference, I'm gonna be mad. Don't make a difference. Okay. Yeah, I mean, that's pretty much what I'm doing. Yeah. So it's just evenly spaced numbers. These are evenly spaced numbers. It doesn't matter because the actual input I'm going to be receiving is not going to be evenly spaced. That's tough. That's tough. At least our low pass filter stuff is correct. Everything seems to be okay up until... Yeah, like even our spectrum looks correct, right? Yeah, like these values look sufficiently random, so it must be something with how I'm calculating the MEL spectrum then. Or our MEL filter bank. Maybe there's just not enough lows. I don't know. Like this can be 5,000, but that won't make too much of a difference, right? Yeah, it's only the last values. It's only the last values. Yeah, I guess Hertz points is also an array. Yeah, so this is an array. Sample rate. So you know, you can do that in Python. It's a bit weird, but yeah. It'll just figure it out for you. So why am I getting a bunch of zeros? Do I just not have enough space here? So this is the calculation. I think they're using Hungarian notation as well. So, yeah, FM minus, float MEL minus. Then going back to this thing, we look at MEL filter bank. Let's run over. Let's go over our calculation one more time. So our sample rate. Oh, well, let's undo this. I thought that would make a difference. Okay, hold on. Maybe the sample rate was too high. I don't think that's it though. Yeah. Maybe the sample rate is just not high. Ooh, maybe. What if I jack up the sample rate and I lower this thing? Do you have a multiplication error? I see the test last number is about 10 times more on the right. Yeah, there's something. So this is the spectrum. So this is the fast Fourier transform value, and then comparing it currently against the MEL spectrum, because the C# library I'm porting does not have any tests, so I have no idea what values I'm supposed to be looking for. So what I'm basically doing is just trying to verify that things work at the very least, and then we'll figure it out later. So have had to fix a few errors already, which is good. We're almost done, but you know what? Yeah, there might be a multiplication error. So let's go back over this. Like, this is the one that's currently released, so that should be good. So Fmax is sample rate divided by 2. This is to mel. I've already verified that these work at the very least. Maybe. Their to mel function actually is a bit different from like all the other things I've read. They use, like, I think everything else uses log 10, whereas the C# library uses natural log. So that might be making a difference. This one is, oh. Oh. Divided by 2. Please don't. Please, if that makes a huge difference, I'm not gonna be mad. I'm just gonna be disappointed. It makes a small difference. Okay. So we're still zeroed out, but we're no longer running into a bunch of things. So now we're slightly more correct. Cool. Let's go back over this. For I in Maldiv, this is still correct. So let n be equal to I as an I64, so that should just be 0, and then we can continue on with our life. Oh. This should be like J or something, right? Because I'm accidentally shadowing, even though it doesn't make a huge difference. It does make a difference. I think it does make a difference. So that should be J. That should be J. That should be J. That should be J. It's possible that that shadow was causing problems. Maybe not. Still looking, still looking. Let's change everything to match how they're doing things then. So this is n an n? N is an integer. Wait a minute. No, that's correct. And then they are. Okay, hold on. Let's just start. Let's just rewrite this. Okay, just rewrite it. Easy. So what is this? This is a I64. So this should be as F64. We'll just do this every single time. Easy enough. These should all be floats. This is a float as F64. Mel begin is dmel times n. Mel center is dmel times n plus 1. And then mel end is dmel times n plus 2. This one is the hertz stuff. We don't use any of that here. And this needs to be I. Change that to I, change that to I, change this to I. And then this is just n as a U size. Doesn't make a huge difference. But yeah, okay. So this is 2 hertz mel begin, 2 hertz mel center, 2 hertz mel end, where these are like melodic values which differ from hertz, I think. I think mel values are like human decipherable, where hertz is just like the raw numbers. I think that's the difference. Then this is F begin divided by df, then we round it as an I64. F center divided by df rounded as I center, then F end divided by df rounded I64. Then this is float 0 for I in, where I is equal to I begin plus 1, inclusive, exclusive, I is less than IN, plus plus. So this is correct. Then we just have some sort of A value. then this is, if I is less than I center, then we'll hit it with I as f64 divided by I center as an f64 as well. Otherwise, we'll hit it with I as f64 minus I center as f64, and then all of that, yep, divided by I center as f64, that's A. And then we add that to the sum, that's a running count. So that's A plus, or A times the spectrum I as a U size. Yes, that's correct. And then we just set the Mel spectrum, N is U size sum. Yeah. And then N is just a, I suppose we can do this as U size to kind of coerce N to be a U size, and then this becomes that. Since we're already casting it everywhere we're using it anyways. That doesn't make a difference though. How nice. Why are the earlier values not being used? It must have something to do with the Mel begin, or pretty much all of these values, huh? MB, MC, and then ME. So Mel begin. I just need to see what these are. I'm so curious. Mel center, and then Mel end. And then we'll do something similar for pretty much everything else. So it's F. Don't really know what F is. I guess that's just like the, actually, we don't need that then, right? These are just like the in-between steps, so I don't care about the in-betweens. This is the I center. I'm not sure what calculation they're doing there, but looks important. Looks important, maybe. Let's see. We'll just look at the whatever we got. So some of these just get zeroed out. And it's only once we get later in. Yeah. Is it the Hertz thing? I really hope it's not the Hertz thing. I really, really hope it's not the Hertz thing. Please don't be the... That's the one discrepancy I've seen. That's the one discrepancy, is that their the Hertz calculation is a bit different from like pretty much everything else. So we can see here that we initially start with 0. That looks okay. Right, that makes sense, is that the first one, beginning is 0, middle is 301, 603, right? But then this one, the next one over, this one still gets zeroed out. So why are we getting zeroed out? What is DF? Am I doing the DF calculation incorrectly? This is F max divided by N max. Is F max too high? Or is my sample rate too high? Is that it? Please don't be that. Please don't be that. Because I can see here that it's based off my sample rate. No. Is my sample rate not high enough? Like what sample rate are they using? Sample rate, sample rate, sample rates. Like here, I can see that they are using something. Target sample rates. Target sample rates is set in the profile, which is here. So it can be 1,000 to 9,600. Let's actually make a note of that. So target sample rates defined as 1,000 to 9,600 in the Unity impl. And then this one, MFCC data count, defined as 1 to 256 in the Unity impl. I don't know. I don't know. Yeah, I guess that's okay. This still doesn't help me. The CD sample rate that I have set up here, that is 44.1 thousand, which is correct. That is indeed the CD sample rate, and it's within the bounds of what they're expecting. So, what is going on? What is dmel used for? So df is used later on. What is df? I just need to know. Print line. df. Phenomenal. It's starting to get late as well. Oh no. I have things I need to do. So df is 3675. Wait. Wait. That's correct. So that's roughly 20,000 divided by your nmax, which is about 11. 11, 5, 10,000. Hey? Wait a minute. Spectrum length. This is the spectrum. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 divided by 2, 6. Sample rate is roughly 22,000. So Fmax divided by, so 22,000 divided by 6 is not 3,000? Huh? What? Am I dumb? So 44100, right? Divided by 2. 22,005 divided by 6. No, I am dumb. Yeah, no, that makes a lot of sense. This is why I don't do math. Not very good at it. Anything having to do with numbers is just mind floods me. I'm better at logic. So that's correct. Rounds the nearest integer to a number. Ooh. Rounds halfway cases away from 0. So I wonder. Looking at this, maybe there's just no mel spectrum sometimes. Yeah, maybe that's okay. Maybe that's totally fine. Yeah. Maybe this is something that's really only testable once you have like a bigger data set. Right? Yeah, could be. Could be. I guess that's okay. right? Because it's like once the numbers, we start getting farther along in our n value, right? Then we actually start being able to get pieces of data. So maybe for really short data sets, it just doesn't work. That could be it. I don't know. That does make it really hard to test, but it's all right, I guess. I think I do need to collect the last few numbers, but we'll do that later. So let's add a to-do. Like, this will always fail. To-do, collect the non-zero numbers and compare them. I guess that's okay. Anyways, I'm gonna push this to GitHub. And actually, let's add a README as well. I don't believe that there's currently a README or a license. Is there a license? I don't remember. Real time lip sync GD. Let me see. Let's add a shout out to you lip sync. A Rust port of you lip sync compatible, I guess connected to Godot via Godot Rust. Let's grab Godot Rust. You know what? This is, I don't think I actually need this, but we can always look it up later. Godot Rust. Just adding a bunch of links. This is my favorite part. Documentation, very good at that. I used to be a business analyst. Didn't really formally study programming in school, which is why my approach to a lot of programming concepts is pretty loose. In theory, should work with any game engine with a C API. At least documentation doesn't have floating point math. Yeah, usually. Hopefully not. As long as I don't need to like put examples, I should be fine. Or examples of the calculations. Is there no license, by the way? Okay, let's add a license. So CP. Yeah, show me all the possibilities. OBS WebSockets license. So we'll throw a license into here. That's my license. Git add all. Add some tests to algorithms. Add README, add a license. There we go. Yeah, so there we go. We can look at, what is it called? Real-time lip sync. It's not under my usual profile, but it's under the VSS project, which I technically own. So that's the intended use case, is for the next generation of this piece of software. So whenever I get around to finishing this. Look at that. Anyways, there's a link, etc. But I'm gonna call it a day for today. Thanks for tuning in. I will be live tomorrow from 7 to 10 p.m. Eastern time, trying to finish up this. I don't know how long it's gonna take me, because we're still stuck on the algorithms, but hopefully, once we get the two hardest parts out of the way, which is the algorithm part, and then you can see here on the right, the lip sync job part, which uses Unity threads, but I can just use raw Rust threads. Once we have that figured out, it shouldn't be too bad. Anyways, you know, give the channel a follow if you haven't already. There's a Discord. There's there's my GitHub, where you can find most of the code that I've been writing, including this thing. and the little stream overlay as well. Look at that. But yeah. That's gonna be it. Goodbye, I guess. Thanks for tuning in.